Hello everyone. In this tutorial video I am explaining you a third lab cycle program, which is to find a factorial of a given number. So how we are going to calculate the factorial by using this equation. So whatever the value that will be get multiplied with the decremented value of the same number each time until it will going to multiplied with the number 1. So I have just set an example saying that if it is a factorial 10 means you have to do like 10 into 9 into 8. So this is the hexadecimal value that we're going to end up with, and this is the decimal equivalent for that. So likewise I have just given some other examples. So if you want to find the factorial of a 2, that means the value is 2 itself. So and if you want to find the factorial of 1, that means you are going to end up with the 1 value itself. Let's see the program and let's check how the program will going to do the same thing. Here I'm just keeping an or not register in order to copy the given variable. So I'm just defining a constant which is by DCD. That means I'm going to set a 32-bit boundary, and I'm just giving the value for which I have to find the factorial. So the address of this constant will be loaded to the R0 first, and again in the next instruction I'm going to fetch the data from the num. That means whatever the data that has been defined in the constant, that will be get loaded into the R0 register. In the next register I'm going to copy the same. Why? Because each time I have to find out n minus 1. Each time when I do the product with the n value, or else if I do product one time, then the n should be decremented. Again it should be get multiplied with the previous product. So I'm just copying the same value to R1 register. Now I'm going to check, I'll decrement it in order to make it as n minus 1. So I'll make this as n minus 1. So the R0 will going to have a value of n, and this will be like n minus 1. So I'm going to compare whether the data that has been given to find out the factorial is 1 or not. If it is 1, there is no need to do the multiplication operation. I can come to the conclusion saying that the factorial of 1 is 1 itself. So what I'm going to do is I'll just compare that with the 1. If it is equal, I'll jump to the last location where I'm going to store the last instruction where I'm going to store the result inside the result variable in the internal RAM. So if it is not, I'm just going to multiply n into n minus 1. So whatever the product that I'm going to get by doing n into n minus 1, that will be stored inside the R0, and I'm going to check whether this R3 is equal to 0 or not. So when I'm going to do this compare instruction, it will, if it is equal to 1, then I'm going to set a 0 flag inside the CPSR register. I'm going to check if the 0 flag is 1 or not. If it is not 1, if it is not set to 1, I'm going to do the multiplication operation, and I'm keep on decrementing the n like minus 1 like that until I'm going to make that n as 1. So I'll keep on doing the product. Let's check my program. I'm going to run this program. So as I said, the address of this constant will be loaded to the R0 register in the first instruction. See, this is the 30. If you go to the location 30, this is the internal RAM location. So I'm just going to go for a program memory. As you can see, the given number or the constant that has been defined, that will be placed in the address 30. So again I'm going to go back to my internal RAM location, which is this one. So so far I have not stored any result, that's why it is showing 0. So in the second instructions, I'm going to fetch that data 0001 to the R0. Now the data has been fetched to the one of the register, and again this is nothing but n. So if I want to keep on decrementing like n minus 1 minus 1 minus 1, so I am going to store the same value to one more register. So I'm just storing that in a R1 register. Now I'm going to make it as n minus 1. So as you can see, n minus 1 is 0. So I'll compare that with the 1. After comparison, I'm going to check whether these two values are less than or equal to. If the given value is less than or equal to 1, so I'm going to stop doing the multiplication. So I'll come to the conclusion saying that 1 is my result, and that will be stored inside the internal RAM. So I'm going to just load this variable address to the R5 register in order to store the result 01, which was in R0, into the address pointed by the R5 register. Now the result that has been, the address that has been stored in R5 is nothing but your internal RAM address. As you can see here, this instruction will going to load here the address of the internal RAM. So now when I use a store instruction, the result will get stored inside the internal RAM here. As you can see, if the given number is 1, it will not going to do any product. It will come to a conclusion saying that the given number 1 itself is the factorial of that number. So I'm going to check for another number. What happens if my value is 2? So I'm going to save it, again rerun it. So 2 means, as I said in the example, 2 into 1 means 2 itself. There is no need to multiply it to the number 1. Why? Because you are going to end up with the same result. So I'll check whether it is equal to 1. If it is 1, I'll assume that the previous, before decrementing, whatever the value that was in the register n, that will be the result of the, that means that is the factorial of a given number. Now as I made it as a 2, just going to rerun this program. As you can see here, again the address will be copied to the address of this num will be copied to the R0. See, again the data will be fetched. Again I'm going to copy that to one more register in order to make it as n minus 1. So in this instruction, subtract r1 comma r1 comma hash 1, it will going to decrement it one time, that means 1. So when I do the comparison, as it is equal to 1, it will jump to the stop label, and whatever the data that is present in a 2, as you can see here, the data that is present in the R0 is 2, that will be stored inside the internal RAM location. See, when I do the comparison operation, it will jump to the label stop, and 02 value will be stored inside the internal RAM. So I'll again recheck the program with a different value other than 1 or 2. Let's say I'm going to use a value 5. You can take a bigger number until since my register is of 32 bit, so you can take the maximum value for which the result will going to end up till FFFFFFFF, or else if the positive value is 7, if you consider a signed number, then the positive value is like 7 FFF and then FFFF. This is the positive value. If your given number is the factorial that lies the value between this positive number, then you can use this. Otherwise you can go for a long multiplication where you can extend till 64-bit result. So what I have written here is for 32-bit, so I'm just going to keep the number small. Otherwise I have to keep on checking or keep on running this loop. I'm going to rerun this program. Let's check. So now in the first instruction I'm going to copy the address, second data, and again I'm going to keep the same value in another register in order to make it as a n minus 1. So I did make it as a n minus 1. So this is n and this is n minus 1. I'll compare it with a 1 value. As it is not equal to 1, so it will not jump to the label. It will come to the next instruction, which is doing a multiplication. as you can see here, the R0 into R1 will get the contents of both these registers, source registers will going to get multiplied, and whatever the product that you are going to get after the multiplication, that will be stored inside the register R3. See, as you can see here, 5 4s are 20, which is in a decimal value. If you convert that into a hexadecimal, you are going to end up with a value 14. So this 14 will be kept in a R0, so that when you do n minus 1 again here, that should be like 14 into again n minus 1. That's why I'm going to check again whether it is equal. As it is not equal while doing this comparison, so as it is not equal, I'm going to again decrement this n one more time. That makes this as n minus 2. As I said, after the first product, the second should be like n minus 2. So I have made it as n minus 2, that is 5 minus 2, that will be 3. Now the product should be get again multiplied with a 3. Again I'm going to check whether this number is equal to 1 or not. If it is not, I'm going to multiply it. Again 14 into 3, that is 3c. Again, as these two numbers are not equal, again it will going to jump to a label fact. Again I'm going to do it n minus 1, so that it will become n minus 3. Now 5 minus 3 will going to end up with 2. So again I'm going to compare this 2 with a 1. If it is equal, I'll just come out of the loop, otherwise I'll keep on doing this same thing again and again. So now 3c into 2, that is 78. And again it was not equal when I did the comparison operation, or when I executed the comparison instruction, the 0 flag was not set. So when both the value become equal, 0 flag will be set. So here in this instruction I'm checking for a 0 flag, as you can see here. So I'm going to subtract it one more time, as it is equal to 1. So this makes, as these two values will equal, as soon as this value becomes equal, the 0 flag in the CPSR register will going to set and make the processor to jump to a specified address, which is specified by the label stop. So now, as my result was already stored in the R2, that result will going to stored in the variable stored in the internal RAM. That address will be kept by the variable result. Now as you can see, 78 has been stored. I'm going to just open a calculator and make sure that a factorial of a 5 is, I'll do in hexadecimal operation. So 5 into 4 into 3 into 2. Again, if you do into 1, the result will going to be the same. As you can see here, the decimal value is 120. The factorial of 5 is 120 in decimal, and if I convert that to 120 into an hexadecimal number, you are going to end up with the 78. Now the same result 78 has been stored inside the internal RAM. So this is how the factorial of the program will going to work. You can just try it for a different numbers and check the result. So thank you very much.